Hey friends, welcome to the YouTube channel all about electronics. So in this video, we will learn how to perform binary addition and the subtraction. So as we have seen in the previous videos, all the digital circuits, for example computers, works on the binary number system. And therefore, all the arithmetic operations like addition and the subtraction are performed in the binary number system. So from the digital circuit perspective, it is good to understand how these arithmetic operations are performed. And first of all, let us understand how to perform the binary addition. So following are the rules for the binary addition. So in the binary, the 0 plus 0 is equal to 0. Similarly, 0 plus 1 is equal to 1, while 1 plus 0 is equal to 1. And likewise, 1 plus 1 is equal to 0 with 1 as a carry to the next column. So in the decimal number system, this 1 plus 1 is equal to 2, right? And the binary equivalent of the 2 is equal to 1 0. So in the binary, when we do the column by column addition, then this 1 will go to the next column as a carry. Therefore, when we are talking about the column by column addition in the binary number system, then 1 plus 1 is equal to 0 with 1 as a carry to the next column. Similarly, while adding the 1 plus 1, suppose if we have a carry from the previous column, then the addition is equal to 1 with the 1 as a carry to the next column. So in the decimal, these 1 plus 1 plus 1 is equal to 3, and the binary equivalent of the 3 is equal to 1 1. Therefore, when we are doing the column by column addition, then in that particular column there will be a 1, while this one will go as a carry to the next column. So these are the few rules for the binary addition. So now let us take few examples so that it will get clear to you. So let's say we want to add these two binary numbers. So as I said, we will do the column by column addition, and similar to the decimal number system, we will start from the rightmost column. So in the rightmost column, we have a 0 plus 0. So as we have seen, this 0 plus 0 is equal to 0. Similarly, if we move to the next column, then we have a 2 ones. So as we have seen, this 1 plus 1 is equal to 0 with 1 as a carry to the next column. So now, if we move to the next column, then we have a 0 and 1 as a carry from the previous column. So effectively, we have a 1 plus 1. So once again, this 1 plus 1 is equal to 0 with a 1 as a carry to the next column. So now, in this last column, we have a 2 ones with 1 as a carry from the previous column. So as we have seen, this 1 plus 1 plus 1 is equal to 1 with a 1 as a carry to the next column. And since there is a no more columns, so we can directly write it as a 1 1. So this is the binary number which we will get after the addition. And to check whether our addition is correct or not, what we can do, we can convert these numbers into the decimal equivalent. So here, let me also show the weight of each digit. So for the first number, the decimal equivalent is equal to 8 plus 2, that is equal to 10. Similarly, for the second number, the decimal equivalent is equal to 8 plus 4 plus 2, that is equal to 14. And the decimal addition of this 10 and 14 is equal to 24. And similarly, if we convert this result into the decimal equivalent, then it is equal to 16 plus 8, that is equal to 24. That means our binary addition is correct. So that is how we can perform the binary addition. Alright, so now similarly, let us see how to add the two binary fractional numbers. So the addition of two binary fractional number is also very similar. So for the addition of the binary fractional numbers, the binary point of the two numbers are placed one below the other. And then after, the same binary rules are followed. So once again, the addition is performed column by column. And once again, we will start from the rightmost column. So in the rightmost column, we have a 1 plus 0, that is equal to 1. So then after, if we move to the next column, then we have two ones. So the addition of the two ones is equal to 0 with the 1 as a carry to the next column. So in the next column, there is a 0 and 1 as a carry from the previous column. Therefore, the summation of this 1 plus 1 is equal to 0 with the 1 as a carry to the next column. And here, we will also put the binary point at the same position. So now, in the next column, we have a 1 and 0 as well as the 1 as a carry from the previous column. So once again, the addition of the two ones is equal to 0 with the 1 as a carry to the next column. So now in the next column, we have a two zeros plus 1 as a carry from the previous column. Therefore, the summation is equal to 1. Then if we move to the next column, then we have a 0 plus 1, that is equal to 1. And then after, in the last column, we have a 1 plus 0, that is equal to 1. So therefore, after the summation, the binary equivalent number is equal to 1110.001. So that is how we can do the binary addition of the two numbers. So similarly, now let us see the binary subtraction. So following are the rules for the binary subtraction. So in the binary, 0 minus 0 is equal to 0, while 1 minus 0 is equal to 1. Similarly, these 1 minus 1 is equal to 0 and 0 minus 1 is equal to 1 when 1 is borrowed from the next column. So in this case, since 0 is less than 1, so we cannot subtract 1 from the 0, and therefore we need to take the borrow from the next column. So these are the binary rules for the column by column subtraction. So the first three rules are pretty straightforward, but for the last one, we will go through the example. So let us say we want to subtract these two binary numbers. And once again, we will do the column by column subtraction. So now if you see in the rightmost column, then since 0 is less than 1, so we need to take the borrow from the next column. And here, let me also show you the weights of each digit. So from now onwards, we will refer all these columns by their equivalent weight. For example, if I am referring to this last column, then I will say that it is the ones column. Likewise, whenever I am referring to this leftmost column, then I will say that it is the eights column. Alright, so now to take the borrow, if we go to the twos column, then indeed there is a 1 in this twos column. And therefore, we can borrow this 1 from the twos column. So once we borrow this 2 from this twos column, then we can replace this 1 by the 0. Because now, this 1 will be given to this ones column. Now one more thing, if you see over here, then the weight of this 1 in this twos column is equal to 2. But whenever we put this 1 into the ones column, then actually its weight is equal to 2. So in the ones column, we can represent it as a 2 times 1. Or in other words, there are two ones. So whenever we subtract 1 from the two ones, then we will get 1. And that is how these 0 minus 1 is equal to 1 whenever we borrow a 1 from the next column. Alright, so now if we move to the next column, then this 1 is already borrowed. So now we have a 0 minus 1. So once again, we cannot subtract a 1 from the 0. Therefore, we need to take the borrow from the next column. So first, we need to check whether we can borrow from the next column or not. So if there is a 1 in the next column, then we can directly borrow it from the next column. But suppose if there is a 0 in this column, then once again we need to go to the next column. So in this case, since there is a 1 in this fourth column, so we can directly borrow this 1 from the fourth column. So in this column, the weight of the 1 is equal to 4. So whenever we borrow this 1 from this fourth column and put it into the twos column, then actually we can write it as 2 times 2. So now if we perform the subtraction, then actually we are subtracting this 1 2 from the two twos. So if we just consider the coefficients, then it is equal to 2 minus 1, that is equal to 1. So in short, whenever we are borrowing a 1 from the next column and putting it into that particular column, then actually it is equal to 2. Because here in this binary number system, the weight of each digit is in the power of 2. So this is the one thing which we need to keep in mind while performing the binary subtraction. Alright, so now let us move to the next column. So in this fourth column, now we have a 0 minus 0, that is equal to 0. And if we move to the next column, or in the eighth column, then we have a 1 minus 0, that is equal to 1. So after the subtraction, the resultant is equal to 1 0 1 1. So now, by converting these binary numbers into the decimal equivalent, we can confirm whether our subtraction is correct or not. So if we see the decimal equivalent of this 1110, then it is equal to 8 plus 4 plus 2, that is equal to 14. Similarly, if we see the decimal equivalent of the 1 then it is equal to 3. So 14 minus 3 is equal to 11. And indeed, if we convert this 1011 into the decimal equivalent, then it is equal to 11. That means our binary subtraction is correct. Alright, so now let us take one more example so that it will get clear to you. So let's say we want to subtract these two numbers. And once again, we will do the column by column subtraction. And once again, we will start from the rightmost column. So as you can see, we cannot subtract 1 from the 0, and therefore we need to take the borrow from the next column. Now if we go to the next column, then once again there is a 0. Therefore, we cannot borrow a 1 from the 2's column. So now we need to go to the next column. And now, since there is a 1 in this 4th column, so we can borrow a 1 from this 4th column. So since we are borrowing this 1 from this 4th column, so now we can replace it by the 0. So as I said earlier, the weight of the 1 in this 4th column is equal to 4. So whenever we are putting it into this 2's column, then we can represent it as 2 times 2. Or we can say that there are 2 2's. So out of the 2 2's, the 1 will be kept in that particular column and the 1 will be borrowed to the next column. So in the 1's column, these 2 can be represented as 2 times 1. So now in the 1's column, if we see, we have a 2 1's. And whenever we subtract a 1 from the 2 1's, then we will have a 1. Similarly, in this 2's column, we have a 2 1's. That means 1 minus 1 is equal to 0. And if we move to the next column, then after the borrow, we have a 0 minus 1. So once again, we cannot subtract this 1 from the 0. And therefore, we need to take the borrow from the next column. So in this 8th column, we can replace this 1 by the 0. Now the weight of this 1 in this 8th column is equal to 8. So whenever we are putting it into this 4th column, then we can write it as 2 times 4. Therefore, in the 4th column, once we take the borrow, then we have a 2 4's. And whenever we subtract a 1 4 from these 2 4's, then we will have a 1 4. So simply if we write this coefficient, then we have a 2 minus 1, that is equal to 1. And likewise, in this next column, we have a 0 minus 0, that is equal to 0. That means after the subtraction, the number is 101. So that is how we can perform the binary subtraction. Alright, so now let us take last example. So let's say we want to subtract these two numbers. And once again, we will do the column by column subtraction. So if you see the rightmost column, then we cannot subtract 1 from the 0. And therefore, we need to take the borrow from the next column. But if you see the next 3 columns, then we cannot get a borrow from the next 3 column. And therefore, to take the borrow, we need to go to this last column. So let us borrow a 1 from the 16th column. So once we borrow this 1 from the 16th column and put it into this 8th column, then we can write it as 2 times 8. So out of the 2, the 1 will be kept in this particular column and the 1 will be given as a borrow to this next column. That means the 1 8 will be kept as it is and the 1 will be given to the next column. So once again, this 8 can be written as 2 times 4. So out of the 2 4's, once again, the 1 will be kept in that particular column and the 1 will be given to the next column. So once again, this 4 can be written as 2 times 2. And once again, out of the 2 2's, the 1 will be kept in that particular column and the 1 will be given to the next column. So in the 1's column, we have a 2 times 1. So that is how the 1 which we have borrowed from the 16th column gets carried forward to this 1's column. So after the borrow, if we just see the weights in each column, then they are 0, 1, 1 and 2. So now in this rightmost column, this 2 minus 1 is equal to 1. Similarly, in this 2's column, this 1 minus 1 is equal to 0. And likewise, in these next two columns, this 1 minus 1 is equal to 0. And if we move to the last column, then now this 0 minus 0 is equal to 0. So that is how we can perform the subtraction in the binary number system. So I hope in this video you understood how to perform the binary addition and the subtraction in this binary number system. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.